Ladies and gentlemen, I want to introduce you to Robert 6000. This is an open reel tape recorder, stereo tape recorder, but it's also capable of all 4 tracks in mono. And by virtue of being able to select which track you want to record, 1 at a time, 2 at a time, it's fully capable of that. But that's not what's important. What's important is some of the things that I've discovered that I just feel compelled to share with you, because when you stumble upon one of these at a Goodwill or a swap meet or eBay, then you're going to want to know this, because this technology is from, this one is particularly from 1965. And there are some, I don't want to say issues, but there are things that you absolutely have to be mindful of when you land upon one of these. And we're going to get started with batteries. This will operate on 4 D batteries. They used to call them flashlight batteries, but flashlights almost don't take batteries anymore. They're rechargeable, or you don't need D batteries because you can operate them on AAAs, for crying out loud. But it also operates on a rechargeable battery. Now, the downside of this one is that it was manufactured in 1968, so it's dead as a doornail. But they're still available. I actually found the exact dimensions, tabs in the right place for 13 bucks. It's not going to be exactly the same, because these tabs, it's actually going to have the kinds of tabs in there with the removable connector, but it's rechargeable. This one was 2.5 ampere hours. The new ones are 3 ampere hours. So that's even a better thing. But the dimensions are critical, and even more critical are these electrical connections. So let's get into that. What I'm going to do is open up this battery door. And all right. What you're going to notice right off the bat is you take the D batteries out and the rechargeable battery into the same battery compartment. The connections on the back side goes in just like this. Now, the interesting thing is that when you have D batteries, the D battery nipple on the top of that battery is going to make contact with this spot right here. Naturally, there's another one and another one and another one. Here's the thing that you have to be mindful of. Batteries back in the day, 1960s, probably even into the 70s, the batteries didn't have all this metal on them. Also, the metal that they did have was typically tiered. So as it came away from the nipple, it actually dropped down a level, dropped down a level. It was tiered. This is metal all the way around, and it's pretty much flat. Well, here's the rub, okay? You put this battery in to this battery compartment, okay? It's going to short out, because with using the rechargeable battery, the negative lead is going to set in there, but it's going to make contact with this little nipple right down here. And that nipple is hardwired to the negative side of the D battery. So this is the negative for the rechargeable battery, and down here is the positive connection for the rechargeable battery. This is manufactured in such a way that when you use an external AC power supply, that external AC power supply has a voltage in there for charging a rechargeable battery, but it also provides external power to use this in lieu of the batteries, the D batteries. The problem became, popping these batteries in, just boom, 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 boom. This one battery for this slot right up here, what I did for this particular battery position, I took a piece of gaff tape, used the battery as a template, cut a circle, laid it on top of that battery top, and then just took a razor blade and just rotated this and basically cut the nipple out. Now, that contact down there cannot make contact with the top of the battery, just the spot that's supposed to have the D battery in it. So now I can put this in here without fear of, creating a cigarette lighter in the meantime. That's something that you need to be mindful of, because in that position, you use a contemporary battery, all right? There's a good chance that what's going on in here, it's going to want to short out. And obviously, we don't want that to happen. By the way, this, it's branded Roberts, but it's really an Akai. And beyond that, okay, it's not just an Akai, but a lot of the internal assemblies that are in this are right out of Germany. You know, if you work on a Uher, U-H-E-R, it's the same stuff, which is why the belts for the Uher fit in a Roberts so perfectly. That is, if you can find them. All right, but what we end up with now is this AC adapter situation. And what you'll see here is a 5-pin DIN connector. Now, I will, point out there is a chip missing in here. It's been cracked, and probably because somebody tried to force it. And I'm going to explain why they probably tried to force it, okay? Because in the case of a DIN connector, and then even the schematic calls for a 5-pin DIN connector. A typical 5-pin DIN connector is going to look like this. But the Roberts unit is going to use a 5-pin DIN connector, but in this configuration, which is a 6-pin DIN connector. This little smiley face, okay, they don't want a smiley face. They want this configuration where 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock, and 10 o'clock. All right, but there's also a pin in the middle, a 6th pin. So what I did was I took a 6-pin DIN connector and removed the center pin. Now it's not going to interfere with the jack. And moreover, there is another little tidbit of information. This collar that goes around the whole connector, well, that's the way it's supposed to be, but Akai, Roberts, in their infinite wisdom, they've added just a little piece of plastic to the molding process when they designed this particular jack. And because they didn't want this particular kind of connector to fit into their jack, but because there's that little plastic in there, what you do is you use a nibbling tool and you nibble right there at that detent and you nibble that out. This is what it looks like left alone, and this is what it looks like to what I've done as far as the modification is concerned. I've got some leads soldered on here, and to save anybody out there from commenting on the fact that, well, your polarities are wrong, this unit operates with what's known as positive ground. When I get these wires connected, you're going to notice that my power supply, my bench supply, I'm actually going to be going positive to this black lead. In this case, black is not negative, it's positive. The red ones, for consistency, if I'm going to be wrong, I'm going to be wrong 100%. These are negative, okay? So with positive applied there, what I've got are pins 1 and pin 5. Pin 1, checking my notes, okay? Pin 1 is the circuit for charging the battery. So it's going to have a different voltage on there because for a 6-volt battery, you're going to be charging it at about 7.2, all right? But this unit strictly wants to work at 6 volts. Now, fresh D batteries are going to have close to 6.2 volts on them, but this thing is accurate down to about 5.6 volts. As the batteries drain, it just maintains its amplification. The electronics are happy, the motor is happy, so down to about 5.6 volts. My fancy labeling basically provides me with the correct connections. All right, so negative to the deck, and I've got my bench supply set at 6.1 volts. So this is going to operate. Just get that handle out of the way. Okay. Have to cut the music short. YouTube police are incentivized to, flag stuff. So there you have it. The Roberts 6000 with a battery modification so that you can use contemporary D-size batteries in there. A rechargeable battery can be obtained to use with this deck, and then you're going to probably end up having to build your own DIN connector, but you'll be able to charge a rechargeable battery. You'll be able to power this unit from that external source at the same time. And honestly, This thing uses about 450 milliamps to run just in the play mode. Okay, with D-size batteries in there, you're going to get anywhere from 6 to 8 hours on this thing. But a rechargeable battery, maybe not so much, but it's still a whole lot cheaper. As it turns out, I happen to have the owner's manual. And what's really cool about, explaining all of the stuff and tape speeds and, recording and playing back and all that kind of stuff, and the fact that it'll record 4-track mono, or it will record stereo on 4 tracks, right? But what's really cool is typically in the back of an owner's manual is going to be all these advertisements for things that they want to separate you from your money for. And one of the things I want to point out is it will take a rechargeable battery to fit in where the D batteries would have been. But the thing that I really want to point out is this accessory down here. It's an AC adapter. And so, they wanted to make it proprietary, so that they can charge you $60 for their version of external power. But nonetheless, I need to build a power supply for this unit. And when you plug the DIN connector in order to be able to recharge the battery, of course, you've defeated the battery from the rest of the circuitry, so it won't run on the battery because it's interrupted while it's being charged. So they also provide the ability to power this externally. But in checking the schematic for that accessory, there's technically 2 power supplies in that brick. Not to mention, there's also an external amplifier circuit in there, which is powered from that as well. It's crazy, but because this is stereo, they figure, okay, well, you've got a speaker in here. We're going to sell you a separate speaker, which uses the same style driver that's in here, but puts it in its own separate enclosure. They charge you for that, but you have to be able to power that. So they included a amplifier in that brick with the 2 power supplies. So they thought of everything. And that's usually the case when they're looking to separate you from your money. So 2 power supplies. 1 power supply for external power is coming off of a transformer, a secondary winding to a bridge rectifier, and that's it. No filter caps. The filter caps are inside here, which is thoughtful. Okay, so secondary, bridge rectifier, DC voltage, filter caps. Now you have the ability to be able to power this externally. The other power supply comes off of a separate secondary winding to a circuit that limits voltage. It has current limiting. It samples the actual voltage and the current and all that kind of stuff in order to recharge the battery gently enough so that you end up with a full charge by morning, and you can use the rechargeable battery and just tote it with you and, take your music to a picnic. They would be able to actually have this thing powered from the rechargeable battery. Great idea. I need to be able to build that power supply, and what I've done through the auspices of Amazon, I picked up some of these DC to DC power supplies. Okay, it'll take up to 35 volts, and with the trim pot on there, you can set the output voltage to pretty much anything. I mean, from I think they said 3 volts all the way up to full voltage, and it will carry about a 3 amp load. That's pretty good, especially for powering this. The charging circuit is going to be somewhat different. It could be as much as 1.5 amps, depending on how dead the battery is. These circuits are going to work perfectly for that. Now, here's the caveat. This unit uses positive ground. Okay, so all of the chassis connections in here are technically positive. So the negative power sources are those that are separated, because from both of those power supplies, the positive leads are tied together to ground. However, always another however, right? I've isolated them with diodes. They're both going to positive, but they're going to be isolated from each other with diodes, including the negative leads that go to external power or the battery charging circuit. So those are all separated with diodes as well. I've spent a little bit of time making some tests, figuring out what's a good voltage for it, what the charging amperes is going to be, how much I need to be able to provide for external power, and I have come up with 6.68 volts each. They both work very well at 6.68 volts each. When I actually measure the voltage while this is operating on external power, it's dead on 6 volts. There's some losses in there, so it's dead on at 6 volts. and the battery charges when it finally relaxes and is not really charging anymore. It's drawing about 30 microamps just to trickle to keep that battery charged. The battery is 6.4 volts. That's the floating charge, and this does great to do that. I've actually sketched out the pinouts for the DIN connector. This 5-pin DIN using a 6-pin DIN connector is pin 5 on this, on the pin view. So if I'm looking at this right here, all right, pin 5 is right here, basically going counterclockwise, 1, 2, 3, 4, 5. That is the external power input on pin 5. Pin 1 is the current limited, voltage limited charging circuit. And then pin 3 is ground, but it's actually positive potential. So the two positive outputs of these power supplies are going to pin 3 through diode isolation. Should have drilled the holes before I put the boards in there. Yeah, well, live and learn. Taking the positive lead from here, and I'm tying it to the diode, which is tied to the positive lead of this supply. So these are diode isolated. That way they won't necessarily interfere with each other. I would also mention that because they are sharing the common ground, the ground itself is actually going to have more current, measurable, I mean in milliamps, but because the electrons are flowing from the negative portions through the battery back to ground, which is positive, and then the external supply negative is going through the circuit to ground. What's going to happen is there's going to be more current on the ground than there would be because two circuits are sharing that ground. I'm sure there's a more ecclesiastical technical term for it, but shared ground works for me. Also, leaving this one lead long aids in drawing heat off of the soldering joint, because as I'm flowing solder onto this spot right here, the hemostat's going to do what it can to protect the body of the diode, but then this will also draw heat off that way. Now, one little thing that I could have done is I could have wrapped this in heat shrink, but this is going to work. I mean, hindsight is 20/20. I do want to do one little thing, and that is take the strain off of that because I don't want this jerking on those solder joints. Since this is going to be larger than the hole, what ends up happening is that I've got a strain relief. Put a little slack in those wires. I like to call that a service loop. Just cinch this up, cut the tail. Now I've got strain relief. Hook these up real quick. Okay, got some little LED lights. Got a heartbeat. So let's see where we are with the voltages. Looking for 6.68, 6.7. It's close enough for government work. Charging circuit, 6.72. They're not arguing with each other, despite the fact that their power supply output positives are tied together, but it's all good. So we'll pull power. And there you have it. Fire in the hole, she said. All right, so positive is our common between both power supplies. 6.72, 6.70. My initial readings were 6.68, but I gotta be honest, using these alligator clip leads, whatever you want to call them, in the bench board, it wasn't really a breadboard arrangement here, and I had it all over the bench, but there wasn't probably enough resistance in those wires to create a couple hundredths of a volt difference. So fire it up and see how it behaves. And we're going to take some readings now with it actually connected to the power supply. And the negative for the external supply is at 6.3 volts. Hitting play, and it's right at 6 volts, which is right where it needs to be. That is cool. All right, that's play with the motor and all the electronics operating. The electronics for the record and playback and all that are not on during a rewind or fast forward and shuttle mode. So there's rewind. Again, 6 volts dead on, and fast forward, 6 volts dead on. Okay, no load, it's going to be hovering around 6.3. In fact, if I even turn that off, you can see that it actually will rise up. I can be excited about that. The battery charge voltage measurement right here, of course, is the power supply and the battery. I could disconnect this, which will move the power supply from it, and it goes back up to 6.7. But with it engaged right now, it's actually going to draw a little bit of current from that power supply to charge that battery to 6.44. And that's right where I'd like it to be, especially for a NiCad and floating voltage and so forth like that. So this thing is all buttoned up. And wanted to take your attention to this belt right here. This is the capstan belt, and this is what I'm going to call the speed change assembly. It's not the capstan flywheel assembly because that's down in here. Okay, that's the actual flywheel. Point being that this belt is no longer available. It's been obsolete for a long time, and they're next to impossible to find. I mean, and if you can find one, it's probably used. All right, so not a good choice. And what happens is that it's been suggested that, okay, well, you can't use the triangular belt, okay, because these belts, these groove in the pulley here is actually at 60 degrees, because the V belt, some people call it a V belt, I call it a triangular belt, but instead of it being square, it's triangular. And the idea being is that the tip, the point of the triangular belt is going to sit deeply into the groove of the motor pulley for the capstan speed change assembly. Well, there's just a slight problem with that. The triangular belt is going to have wall dimensions of 0.062 inches. And that's a wonderful thing because it's going to provide as much surface, friction, tension, surface area to work with to do the job properly. And the triangular belt, of course, is going to have It's going to set in those grooves absolutely perfectly. Problem being is that when you use a square belts are going to have 90-degree corners. So it's not going to want to fit into that 60-degree groove. It's like trying to use a 78 RPM needle to play LP records. The needle's just too large. Well, if you go with the .062 dimensions, the wall dimensions of a triangular belt, you go to use a square belt that would also have .062 inches on its walls. All right, that's going to leave an awful lot of belt above the pulley. Okay, and I can promise you that what's happening here is that when that larger belt, which you say larger, but it's supposed to be .062, but when that larger belt is in here and it's square, it's not going to clear. I have gone with a square belt in this case, all right, but I went a size smaller, okay? The .062 of the triangular belt and the .062 for a square belt, square is going to be the problem, simply because the tip of that corner is going to be exposed and most likely rub on some of the inner mechanism that's in here. So I went with a smaller belt, which is going to be the .046. Okay, so now it's smaller, but by virtue of that, now I've got even less surface area to work with. So in that case, I went with just a slightly smaller belt. I went from like 11.5 in the .062 to a 11.4 of the .046. And that is working, I'm going to say roughly 98% of the time. It being a thinner belt, there's going to be a lot more oscillation in the belt as it's running. And that can be a potential problem down the line. All right, is it something I'm going to be concerned about for now? Yes, just to be honest. But you get to a point where, you know what, it's either fish or cut bait. You know, choose. This pulley up here is for the capstan. There's another pulley right down here, which is for the reel tables, for fast forward, rewind, call it shuttle. And that belt, as it turns out, I had one. Triangular belt, right size. That's a new belt, but it's my last one. But I'm going to play with it for a while. I'm going to have some fun with it, and then it's going to take a very prominent place in my display. Also, I will point out that there is a belt for the tape counter, okay? And that is, of all things, that's a round belt, okay? And so that one has been replaced as well. So what this has is new belts throughout, and with any luck, it will have a tremendous amount of shelf life. So now we'll get to maybe demonstrate this unit. This is a tape that I made of non-YouTube police music. We'll see how this sounds. So here we go. All right. Well, actually, it's supposed to be 7.5 inches per second, so we'll change speed to 7.5. Okay. Leader runs through and zero the counter. Okay. And I'm going to turn the speaker off in a moment, okay, because the audio is actually going to camera 3.
I'm an expert at overthinking things that I shouldn't. You come across as a cool guy, someone who's the opposite.
This has been fun. I got really excited when this lost puppy arrived on my doorstep. It's what we call a rescue. It's one of the 6 R's. And I want to thank you for watching. I really wouldn't mind hearing from you. You can get some of your comments and little tidbits. Share some of your own stories, man. I mean, it's all cool. We're all kind of an elite club here, where we really have an affection for this sort of thing. Subscribe to the channel. That lets us know how good we're doing. In addition to your comments, and you can always give us a thumbs up, because that would be like really cool too. I'd like to know that I'm doing something right, and I don't know that without reading my mail and checking with any of my ex-wives. So it's all good, right? Thanks for watching. Enjoy.